Welcome to another video of Engineering Economics, INEN 2373. What we're going to do in this video is do the sensitivity analysis with two parameters at a time. For purposes of that, we consider the same project we were working with in last video. If you have not seen that video, please go back and check the previous one. So in this case, the initial investment is $1,000, minimum attractive rate of return 10%, the life is 10, annuities are 400, and the salvage value is 150. And we're going to compute again the present worth, and the formula was, well, in the present worth, we would just need to take the negative value of the initial investment plus the present value of the discount rate is 10%. The number of periods is 10, and the annuities are 400 plus the present value originated by the salvage value, which we're going to discount by the same minimum attractive rate of return 10%. We have to wait 10 periods to receive the salvage value, and we'll receive it only once, so this future value would be 150. And the present value is the same as we have computed before, $1,515 with 66 cents. Now we continue with our two parameter time analysis, and let's say that we want to change these parameters every 5%, and same from minus 25 to plus 25. So and the parameters that I'm going to use are, let's try for the minimum attractive rate of return and the annuities. So minus 25, that would be 1/4 less, and we would start at $300 for the annuity, and then we'll consider steps of say 5%. 5% of 400 is 20 units, so we're going to go with 320, and we're going to use this all the way to first 400, and we want to go all the way up to 20% more, which is 500. And we're going to do, that's the values for the annuities, right? Now we're going to consider the values for the minimum attractive rate of return. Minimum attractive rate of return starts at 10%, so 25% less of that would be 7.5%, and we can change that to 8%, the steps of 5%, and we will go all the way up to 25% plus, which would be 12.5%. And now we have this region with annuities and minimum attractive rate of return changes. We make reference to our present worth, and now we can select this area, compute data, volume analysis, data table, and the top row is making reference to the minimum attractive rate of return, so we select that cell, and the column in that region is making reference to the annuity, so we select the annuity for that purpose, and the rest of it is just formatting. And once we have this, it's very easy to generate other ways to visualize the information. Maybe higher is better, and if that's the case, we can create this graph. And now the greener is higher, and you can see where is the combination for which we have the better option. Of course, the better option would be when the minimum attractive rate of return decreases, and for computation of the present value, that is, and the annuities increase to the highest possible value, which is 500. And you see how the trade-off between these two parameters is affecting the present world. So you can do this for any combination of values for the present value and the parameters that are involved in computation of the present value. And I hope you see this video something useful for your assignments.